So we understood the first obstacle force, which is air drag force. Now let's go to the second obstacle force, which is rolling resistance. And this force will come into existence as soon as tires start rolling. And just to give you an idea of it or feel of it, so all of us would have driven a bicycle somewhere in the past. So in situation 1, let's say the tire is completely pumped with the air, and when we drive in this condition, we able to drive very smoothly. But let's say in the second situation, when the tire is partially filled with the air, and all of us have experienced that in this condition we have to put a lot of effort, and this extra effort is coming because of this rolling resistance force. And just to give you a tips of it, so whenever you drive the vehicle, make sure that your tire is completely or perfectly filled with air as per the specification provided by the car manufacturer. But let's dig deeper how this rolling resistance force comes into the picture as soon as tire starts rolling. So in a practical sense, tire will never be a perfect circular shape. It will be having a kind of flat when it get contacts with the road. Just to give you an idea of it, if this is the tire, so at the contact with the road, it will be kind of flat here. And here I'm just exaggerating it. So the tire shape, when it contacts with the road, it will be kind of flat line here. It will be the kind of line contact. So let's say a tire is rotating with respect to this center, and motor is trying to move this tire in a forward condition. So we get some sort of intuition that this point is going to get some sort of obstacle force in this direction, and because of this the motor has to provide some extra effort, and that extra effort is equivalently described at the vehicle level as a rolling resistance force towards the back of the vehicle. And the amount of rolling resistance force will be calculated using this formula, which is mu mg cos theta. What is mu? Mu is the coefficient of rolling resistance, which we will get from a data sheet or some experimental value. M is nothing but the mass of the vehicle, and g is the acceleration due to gravity, and theta is the gradient of the road. So this is all about a rolling resistance force. So we understood the second obstacle force, which is the rolling resistance force. Let's go to the third obstacle force, which is the gradient force. And this force will come into the existence as soon as car starts climbing on the inclined road. And it happens because of the component of the weight of the vehicle acts backside of the car, and the amount of gradient force will be calculated using this formula, which is mg sine theta, where m is the mass of the vehicle and g is the acceleration due to gravity, and theta is nothing but the gradient of the road. So this is all about the gradient force.